So my name is Angelina, and what I'm going to show here is agroecological practices that we're practicing here. Here it's mostly intercropping, and we have intercropped two different families, the Aliaceae and the Cucurbitaceae. So cucumber and onion. These are bulb onion that were planted for the purpose of harvesting seeds. So part of it was for seeds production, but second is the principle. Third is the way that it helps us to repel some pests from that can attack or that can infest the cucumber plant. So there are different kind of crops that can be intercropped, as long as you know you should not intercrop the same families. It can be maize and beans, or tomato and kale or sukuma wiki. They are different families. So the intercropping process is not that complicated. It's just a system. You can intercrop any as long as they are not the same families. So for this one, they are compatible. There is no way that one crops affect the growth of another crop. So for the cucumber, it's a trellis plant that grows upward, and the onions stay under a lower part of this nike. So the growth is quite not interfering from one another. So this is syntropic.
Syntropic, you said.
Yes, syntropic system, and it's one of agroforestry system where you intercrop different crops at the same time, and you make sure that you utilize the things inside this system as the part of nutrient increment in this system.
Oh, fantastic.
We are not taking anything from outside the system except when we were establishing it. So the system works like, in this row on itself, it has the plant that are in front part and the back part. So the front is east, the back part is west. So the one that are in back part, they are the one that can tolerate shade. You see? So the one that are in east tend to get a lot of sunlight and then create shade for the one that are in west, but still they will grow, and there will be a moment that they will get fully sunlight for their normal photosynthesis activities, and that will not affect their growth because they were shaded before. So that is it. And
so, okay, what the importance of syntropic at all? Okay,
so we are trying to make sure that we get as many plants as possible in the one niche, and they can all depend on each other's. What I'm trying to say is some of them tend to have a lot of biomass. For example, Gliricidia. So Gliricidia, this patch.
So Gliricidia like that one, okay, I can see.
Yeah, that one, that one. They have a lot of that one, yes.
Biomass.
So when you do the chop and drop, it means they continue putting much more nutrients and yes.
So can syntropic, this technology used to revive the dead soil?
Yes, it can.
Okay, so it's one of the technologies used to revive the dead soil.
Yes.
So you can recommend even farmers to use such technology, and I can see it's a very cheap technology that farmer can afford.
Yes, they can afford. It just need a lot of much work when you establish it. Yeah, for example, we are in a very dry place. So we reach at a time where there is a very driest season, and still the plants survive.
Oh, that's cool.
Yeah.
In among the 13 principles of agroecology, we apply one of the principles, recycling. So we recycle different materials from the environment. So instead of taking these boxes and papers, use the papers, instead of burning them, we use them as source of compost. And we use this compost for to plant different crops in the vegetable crops, as you have seen in previous. Also, we use the vermi wash as the booster. You can see here, we use this vermi wash as the booster, also as the biopesticide. So this is one of the importance of this vermi compost as one of the agroecology practice we use here at the Living Lab 3 and at the SAT Farmer Training Center located in Morogoro, Tanzania.